is an aerial view of Space Launch Complex 2. And the arrival of the Delta booster occurred on November 29th, 1995, where it was taken to the pad for erection into the service tower, and then the service tower moved into position around the launcher for installation. The Delta first stage has a single booster manufactured by Rocketdyne. And here we see the mobile service tower, or the gantry, moving into place now around the launcher, which is in the foreground, so that it can be attached. And then the interstage was erected atop the vehicle, into which the second stage and its engine will be inserted. And here we see the second stage being hoisted into position. And the second stage has a single engine manufactured by Aerojet. The second stage was installed on top of the first stage on December 1st, 1995. Here we see it lowered into the interstage adapter. And then the 6 or 9 solid rocket boosters manufactured by Alliant Tech Systems were installed in sets of 3 over a 3-day period between December 5th and December 7th. And as we said, 6 engines, 6 boosters ignited on the ground, and then 3 at altitude about a minute after launch. And again, we're live at Space Launch Complex 2, where our only concern in the countdown this morning is surface winds. We're watching that closely because the vehicle does tend to move some in the wind, and that affects the guidance system. We can see data on the guidance system trying to account for the motion of the vehicle as it moves back and forth in the wind. And we're about to enter our built-in hold at T-minus 20 minutes. This is a 10-minute, or rather a 20-minute built-in hold, and then we'll have one additional hold at T-minus 4 minutes, which will be a 10-minute hold. And we're now at T-minus 20 minutes and holding. This is Delta Launch Control.
One minute into the hold.
Locks, top to 100% on verify 100% locks float switch operation, a minimum of 3 cycles, report complete.
Roger.
Currently, we have a cold front approaching Vandenberg. Currently, it's in between San Francisco and Monterey. However, ahead of that cold front, there are some impulses coming down, which is causing our increase in surface winds around Tower 102 and the adjacent waters off the coast here. We have issued a weather warning for South Vandenberg. This is very localized near Slick 6 and Trank Peak. The winds for the surface at on South Vandenberg are to 35 knots, and on Trank Peak above 1,000 feet, expecting winds of around 60 knots, and this should stay. Valid time on this forecast is at 3:10 local this morning. Current sky condition is 2,000 scattered at the airfield, visibility unrestricted. NEXRAD radar is currently showing strictly ground clutter. The wind trend over the past hour, it has increased. We have had a bump to 28 knots, a gust of 28 knots. However, in the past 5 minutes, winds have started tapering off again and are running in the gust of 22 knot range with a mean wind speed or sustained wind speed of running around 20 knots. We expect the wind condition to hold in this range. We are not expecting to violate the 29 knot constraint, but we are going to be very close to it, and we are monitoring the situation very closely. Are there any questions?
LWRC, what's the current temperature, sir?
Current temperature is 52 degrees.
Thank you. Flight Director, any questions, sir?
Thank you. No.
Roger. Thank you, LW.
LW out.
This is Delta Launch Control at T-minus 20 minutes and holding. We have 14 minutes 30 seconds remaining in this built-in hold. And as you've heard, we've just had a weather briefing, and that pretty much sums up where we are. Our only concern is the surface wind at this time. We're not watching, we're not working any technical problems on the vehicle other than we're seeing the vehicle rock some in the wind, and the guidance system is trying to compensate for that. And when we went through our engine steering checks, we could see the guidance system trying to allow for the wind out of the pad. So assuming the winds continue to taper off as expected, then we would be launching at 3:24 at the opening of a 17-minute launch window. At T-minus 20 minutes and holding, this is Delta Launch Control.
Brett, I'll be off the net for a moment. Copy. Cycling main lock strengthened.
NASA quality's ready.
NASA safety. NASA safety's ready to proceed. ALM,
ALM's ready.
launch vehicle manager.
Launch vehicle managers, go.
NASA mission director.
NASA mission directors, go.
NASA management.
We're ready to proceed.
Thank you.
This is Delta Launch Control at T-minus 20 minutes and holding. NASA Launch Manager Floyd Currington has just polled his team as to spacecraft and launch vehicle readiness, and as we heard, we are go, and he is delivering that status to McDonnell Douglas Flight Director, and that in turn will be passed to the Launch Director that we are ready to pick up the countdown when we come out of our 20-minute hold and proceed toward our next hold at T-minus 4, which is 10 minutes in duration. At T-minus 20 minutes and holding, this is Delta Launch Control. This is Delta Launch Control at T-minus 20 minutes and holding. We have approximately 8 minutes remaining in this built-in hold. We've just received word that another wind balloon has been released. That's now passing through an altitude of about 3,900 feet. And we've also heard that over the course of about the last 10 minutes or so that we have not exceeded our red lines at the pad for surface winds, and they do see a trend in the right direction. So at this time, our only concern is wind, and that seems to be improving.
Go ahead, Locke.
Again, there is a 40% chance of not meeting our launch weather criteria this morning. At T-minus 20 minutes and holding, this is Delta Launch Control.
Verify on link 52 that you are not transmitting that link at this time. Is that correct, sir? Let me check it and I'll let you know. Thank you. RCO? That's on the stages. That link is down. Understood. Thank you. We should bring it back up here in a little while. Sounds good. Thank you, sir. Yeah.
19 minutes into the hold. Mark?
All personnel, this is the launch conductor. Following personnel report ready to proceed with the countdown. FSC.
Ready.
BPC.
Ready.
ETP.
Ready.
DEA.
Ready.
MEA.
Ready.
EEA.
Ready.
VP.
Ready.
TSC.
Ready.
MSC.
Ready?
HYE.
Ready.
Fuel.
Ready.
SSC.
Ready.
SSP. Ready. PLC.
Ready.
LCE.
Ready.
FMA.
Ready.
VE.
Ready.
ACC.
Ready.
CSO.
Ready.
Logs.
Ready.
ROC.
Ready.
RCO.
RCO ready.
MIFCO.
MEFCO ready.
Copy. FISPO.
Ready.
RC.
Ready.
MDA Chief Engineer.
Ready. Ready.
MDA Launch Director.
Ready.
NSC reports spacecraft is ready to continue with the countdown.
Ready. CDRs, EPC will be momentarily in my station.
Copy. VPC.
RCO on top 15. Yes, sir. Yes, just to let you know, dummy loads are finished. CT sites are keyed down at this time.
All personnel, this is the launch conductor. At this time, we are tracking no vehicle problems. We are positioned to come out of the T-minus 20-minute built-in hold. We are watching closely our ground winds, which have increased slightly.
Up to 46.
Check.
That's correct, sir.
Okay, thank you very much. We're looking at mid-20s, gusting up to 24 from the direction from which we're vulnerable at 29 knots. Upper level wind data has been favorable up to this point as well.
Yes, sir. I'll arrange it, sir.
Nineteen minutes into the hold. Mark?
Launch conductor. Launch conductor. Rogers, launch director. You may resume the countdown at the end of the built-in hold. Roger. All personnel stand by for release of the hold.
This is Delta Launch Control at T-minus 10 minutes, 25 seconds, and holding. Correction, we're at 20 minutes and holding with approaching 1 minute, 15 seconds remaining, and we're getting ready to come out of our built-in hold now in 5, 4, 3, 2, 1, and we're now at T-minus 20 minutes and counting. And we have one remaining hold at T-minus 4 minutes, which is 10 minutes in duration. And very shortly in the countdown, we'll be going through a series of activation and checkout of the range safety system on the launch vehicle. And we continue on toward a liftoff at 3:24 a.m. Pacific time this morning. At T-minus 19 minutes, 18 seconds and counting, this is Delta Launch Control. This is Delta Launch Control at T-minus 17 minutes, 20 seconds and counting. We'll look now at a tape of the Polar spacecraft being prepared for launch here at Vandenberg Air Force Base. Spacecraft arrived on a C-5 military transport plane on October 16th, 1995. And after offloading from the plane, it was taken to NASA's Building 836, where a series of tests and functional checks were run, as well as subsystem testing to assure that the spacecraft was ready for flight. And there were a series of final checks to put the spacecraft in its proper configuration and to verify that all the subsystems supporting it, including power and attitude control, were ready for flight. Solar arrays on the spacecraft generate a total of about 500 watts of power after launch. The spacecraft was then prepared to be transported to a hazardous processing facility for fueling, loading of its hydrazine. And here at building 1610, we see the fueling operations, where the spacecraft was loaded with about 600 pounds of hydrazine. And then it was transported about 1 mile from building 1610 out to Space Launch Complex 2, where it was mated to the Delta second stage. And the spacecraft is being hoisted into the gantry, and also attached to it at this point is the Delta third stage solid rocket motor, the Viacol Star 48 module. Here is the fairing being installed, the 10-foot fairing, which is in 3 sections. And each of the 3 sections installed around the spacecraft, closing it out for flight. This occurred on January the 29th this year. And we just received word that the spacecraft has just been placed on internal power for launch. So the Polar spacecraft is ready to begin its mission today. And we're standing by at this point of the countdown for a final readiness check that the spacecraft is ready to fly. We continue not to work any technical issues on our countdown this morning, so we're just watching the surface winds, but at this point we are green and expecting to launch at 3:24. At T-minus 12 minutes, 45 seconds and counting, this is Delta Launch Control.
Go send 5-second arm only on your mark.
On my mark. 3, 2, 1, mark. +1, +2, +3, +4, +5. Function removed.
SSC report RS1 arm and RS2 arm on momentarily.
Received.
FSC report CDR arm monitor on momentarily.
Received.
TM2 verify arm off.
Arm off.
FSC telemetry and CDR internal power off.
Off.
SSC range safety 1 external on.
On external.
Range safety 2 external on.
On external.
Fuel test fuel level sensor off.
Off.
FSC battery discharge off.
Off. BP. Go ahead. Helium bottle pressure is 38.72.
Thank you.
is Delta Launch Control at T-minus 9 minutes, 55 seconds and counting. Range Safety has just completed going through their checks of their systems on the Delta rocket. The Spacecraft Mission Director has just completed polling his team, and all of the polar systems are reported go for launch, and the spacecraft is on internal power. Surface winds are continuing to moderate, and we do expect to have green conditions at the pad for winds at launch time, even though they're still a bit gusty. And we just had reports that our latest upper-level balloon is reporting back green data. We'll be going into another hold at T-minus 4 minutes, which is 10 minutes in duration. We're right now at T-minus 9 minutes, 6 seconds, and counting. This is Delta Launch Control.
RCO, LCDR on 15.
RCO, go ahead.
Roger that, sir. Just want to let you know third stage transmitter is coming up shortly.
RCO copies.
Cycling main lock tank vent. T-minus 8 minutes. Mark?
Locks PSD purge open.
Open.
TM1 verify fabric and engine heaters go.
Go.
LCE initiate LCE check functions.
Roger.
Locks verify locks umbilical purge closed.
Closed.
PTO verify overflow line temp rise is less than 12 degrees.
Roger.
RC, this RC on top 15. Go ahead, RC. Be advised, the personnel at your viewing site are being moved by the LST at this time for LARA concerns. Once those personnel are moved, will be green for LARA. Okay, fine. Thank you very much. RC, we have an estimate for the
T-minus 7 minutes. Mark?
TSC turn on third stage TM as follows. Telemetry system external power on. On. Transmitter external power on. On.
RC, this is RC on top 15. Go ahead, sir. Be advised, they're going to release the J4 balloon. However, if the motor...
TSC telemetry system internal on. On internal. Transmitter internal on. On internal. Select instrumentation bus voltage. Roger. PEA verify VE locks bleeds and lock start tank binning. Binning. Locks top to 100% and verify 100% locks float switch operation a minimum of 3 cycles.
Roger.
Locks allow locks to boil off. Maintain locks level between 99 and 100%. Report complete.
Roger. T-minus 6 minutes. Mark?
TSC arm power ready on. On. Third stage SNA arm on. Arm received. First stage SNA arm on. Arm received. Second stage SNA arm on. Arm received. BPC report locks relief plenum pressure.
8.9.
TM1 report locks relief plenum temp.
54.5 degrees. Copy.
LCDR verify pad surface winds go for launch. Go.
T-minus 5 minutes. Mark? TSC telemetry system transmitter external command on. On. Timer at T-minus 4 minutes. Hold the countdown clock. Roger.
This is Delta Launch Control at T-minus 4 minutes and holding. We have just entered the built-in hold, which will last for 10 minutes. And in just about 2 minutes, we'll have the final polls from the NASA Launch Manager, and we should be getting a final briefing on the weather.
RC on top 15. Yes, sir. Do you have an estimate for when the folks are going to be cleared out of the viewing area? They're expected to be out by T-minus 5 minutes. However, if they're not clear, the MIFCOs will be sending a red.
And the launch team has cycled the liquid oxygen fill and drain valve, verified that that's operating properly, and they're getting good data. And we have no concerns with our first stage propulsion.
Thank you very much.
So we'll be standing by here in just a few minutes for a final weather briefing and our final polls for picking up the count. At T-minus 4 minutes and holding, this is Delta Launch Control.
NASA Launch Manager General 20. I'm going to delay my poll until we get the weather update, which should be only just a minute or two. Launch Weather Officer on the Weather Conference Net. Our current status is all of our constraints are green. The concern we have with the winds, we were getting gusts up to 28 knots within the past hour. However, within the past half hour, the wind trend has been on decreasing. Winds are decreasing, and we expect them to remain favorable in the range of 18 to 22 knots throughout the launch window. Are there any questions?
Yeah, this is the flight director. I assume you're now giving us a 0% violation probability. for launch
Yes,
time?
we are very low. I wouldn't put it necessarily at 0, but definitely around 10% or less.
Roger that. Thank you.
Are there any other questions? LWO.
Thank you, LWO.
This is NASA Launch Manager on Channel 20 for the final readiness poll. NASA Quality.
NASA Qualities go.
NASA Safety.
NASA Safety's go.
ALM.
ALMs go.
Launch Vehicle Manager.
Launch Vehicle Managers go.
NASA Mission Director. Understand you are go and you're on internal power. NASA Management.
We're go, Floyd.
Console operators only. Range personnel are still working an issue. FSC. FSC on channel 1. Report ready.
Ready.
BPC.
Ready.
ETP.
Ready.
BEA.
Ready.
MEA.
Ready.
EEA.
Personnel are on the bus and moving
VP.
Ready.
past Building 7000.
DSC.
Ready.
MSC.
Ready.
HYE.
Ready.
Fuel.
Ready.
Logs.
Ready.
SSC.
Ready.
SSP.
Ready.
PLC.
Ready.
LCE.
Ready.
FMA.
Ready.
VE.
Ready.
NSC.
Ready.
ACC.
Ready.
CSO.
Ready.
FISPRO.
Ready.
RC.
Ready.
MDA Chief Engineer.
Ready.
All personnel post-launch securing will be conducted on Channel 5. Flight data will be reported real-time on Channel 1. Following personnel switch to Channel 5 after liftoff is confirmed for pad securing. Chief Launch Conductor, ETP, PLC, SSC, Docker, LOX, Fuel, TSC, CSO, MSC, BPC, SSB, FSC, ACC, LCE, and QAM. All personnel, if a condition that exceeds a launch constraint is observed during the final 4 minutes, the observer shall announce hold on the launch countdown net, blockhouse channel 1, and state the reason. All personnel remain on channel 1 until after launch. In the event of a hold after T-minus 4 minutes and before T-minus 2 minutes, recycle will be performed per Appendix K, beginning on page A003-17. In the event of a hold after T-minus 2 minutes, recycle will be performed per Appendix K on page A003-14. Appendix K is the yellow pages. In case of engine cutoff or no vehicle liftoff by T+5 seconds, recycle and safing will be performed per Appendix L on page A003-41. Appendix L is the red pages. Safety will position the TV cameras to monitor VE log bleeds and log start tank vents throughout liftoff.
Roger.
DSC calibrates second stage TM 30 seconds prior to picking up the count.
Roger.
FSC calibrate first stage TM 30 seconds prior to picking up the count.
Roger.
DSC calibrate third stage TM 30 seconds prior to picking up the count.
I concur.
Roger. Thank you, DSC. All personnel will be advised at this time we're working an issue. Personnel clearing a toxic area or a new hazard area. We may not be able to come out of the hold as planned. Continue to monitor your systems. As soon as the area is clear and we get it clear from the range, we will resume the count after we pick in UT0.
This is Delta Launch Control at T-minus 4 minutes and holding. We have approximately 1 minute 12 seconds remaining in this built-in hold. However, we've received word that we expect to extend that hold due to the necessity to clear some personnel out of the danger area due to the winds. And I expected that will take just a few minutes, so it's not going to be a significant hold. But we're standing by now to get official release of that hold. There is nominally about another 35 seconds remaining in the hold. And we'll be following the test conductor for when he gets official word that they have a green condition and all personnel have been cleared out of the area. That concern is due to, should there be a mishap, there would be a toxic plume that could flow into an area located where personnel are located. At T-minus 4 minutes and holding, this is Delta Launch Control.
T-minus 4 minutes and counting.
Noted personnel accomplish items 2 through 6. Locks establish and maintain locks topping at 100% level.
Topping to 100%.
Fuel main fuel tank pre-press open.
Open.
Umbilical purge open.
Open.
SSC RF systems internal on.
Internal.
Transmitter internal on.
Internal.
FMA report PCM go.
Go.
SSC guidance system internal on.
Internal. Internal.
FSC telemetry and CDR internal power on.
Internal.
RCO perform final C-band and TM checks.
RCO, roger.
TSC telemetry system internal on.
Internal.
Transmitter internal on.
Internal.
FSC battery discharge on.
On.
Ordnance power on.
On.
EPAC internal power on.
On. Internal.
SSP vent umbilicals.
Minus 3 minutes.
BPC vent helium umbilical.
Roger.
FSC battery discharge off.
Off.
SSC range safety 1 internal on.
Internal.
Range safety 2 internal on.
Internal.
FSC EPAC battery heater off.
Off.
Launch ready on.
On.
NSC report spacecraft go.
Go.
This is Delta Launch Control at T-minus 2 minutes, 22 seconds and counting. And as we heard, we did pick up the countdown on time. The blast danger area is clear, so we're proceeding toward a launch on time at 3:24 a.m. Pacific time.
NSC pulse suppression water on. MSC pulse suppression water on.
On.
SSC hydraulic pump control on.
On.
DSC data recorders to high speed.
High speed. $90.
SSC hydraulic pump external on.
External.
HYE check hydraulic pressure go.
Pressures go.
SSC hydraulic pump internal on.
Internal. 70.
ROC, report range green for launch.
Range green.
Launch conductor, this is launch director, you go for launch.
Roger.
60. Water flow.
Now at
45.
T-minus
SSC
45 seconds
disconnect
and
enable
counting.
on.
T-minus 35.
Let guys go. Hydraulics go.
30.
We're now at T-minus 30 seconds, continuing on toward a on-time launch. T-minus
20.
20 seconds. Green board here in the Mission Director Center.
15.
15 seconds.
13. 12. 11.
We're now at 10 seconds.
Start
9,
enable.
8, 7,
Green board.
6, 5, green board, 3,
2,
Go for main engine start. 1, 0, and liftoff. Liftoff of Delta 233 on the polar satellite, bringing solar physics down to Earth. Pitch program is in. Roll program is in.
+18, 19, +20.
Timer announcement number 9, page 102. All personnel, terminal count is complete. All personnel, switch to net 5 for securing.
44, 45, 46.
CSO, pad pressures are within personnel.
Velocity now 2,100 miles per hour, 17 miles downrange.
To amber.
61, 62, 63, 64, 65, 66.
Main engine and both verniers continue to burn well.
85, 86.
We have 3 solids off. The other 3 solids are off. All 6 of the first set are off. Attitude disturbances were very light at separation of the solids. Main engine and vernier continue to burn well. The second set of 3 solids also burning very nicely, very symmetrical.
One minute, 50 seconds into the mission.
Thermal counts complete.
All engines still burning well. Beginning the tail off. Tail off is symmetrical on all 3 solids, and we have solid motor burnout.
129.
33.5 nautical miles
We have
downrange.
solid motor jettison. All 3 are off. Attitude disturbances, a little bit, but very easily corrected. I have both verniers and main engine continuing to burn well. We've gone to the main LOX tank pressurization, and the pressurization looks good.
Velocity 4,494 miles per hour.
Guidance has just been initiated. Yeah, taken care of.
46 miles downrange.
Engines continue to burn well.
Velocity 6,288 miles per hour. 48.5 miles downrange.
RCO on top 15.
Continuing to burn well.
Three minutes, 20 seconds into the flight.
Very quiet, virtually no vibration on the flight so far.
$58 miles downrange. Velocity 9,228 miles per hour.
Some pressures all look good. No vibration at all on this mission. It looks very clean.
4 minutes, 10 seconds into the mission.
We have the fuel float switch, LOX float switch, MECO enable. And we have MECO. Both verniers continue to burn well.
77.7.
And we
Statute
have
miles.
vernier engine burnout. We have stage 1-2 separation. And we have second stage ignition. Chamber pressure is up and looking good. Fairing separation.
12,000.
Fairing separation looked good.
12,485 miles per hour in velocity. 79 9 miles downrange.
Looks like a nice clean second stage at this time. Very little to report. Main engine continues to burn well. Pressures and temperatures all look good. Batteries all look good.
Orion aircraft will have acquisition in about another minute and a quarter.
Decimal 6 Zulu. I understand. Thank you very much, sir. Thank you.
Velocity now 14,242 miles per hour. 96.7 miles downrange. Vandenberg will have data until about 7 minutes into the mission.
We're getting our normal roll jet activity during the burn, well, actually a little lighter than normal. Quick indications are we had a LOX depletion cutoff with approximately 470 pounds of residual fuel. That's 99.78 PU. That is a quick look calculation.
Orion aircraft has signal lock and good data.
Main engine continues to burn well. Tank pressures look good. The roll jet activity remains quite light. The response is correct.
And this is a replay of launch right on time at 3:24. Good data from the Orions. And we're about to lose the Vandenberg data. And we're not sure why we don't have the Orion data, because Orion reports they have lock.
RC and RC on 15. RC on top 15. RC on, sir. RCO. Gentlemen, I would like to take this opportunity to thank you for your support and your effort for today's operation and yesterday's evening. Again, from McDonald, it was your professionalism has shown great.
9 minutes into the mission.
We appreciate working with you folks, too. It's been a nice experience. RC, this is Major Absar ROC. Just wanted to echo that back to your staff and would like to also get together with you sometime. We'll stop here sometime. Okay. Thank you, sir.
Indications that we still have some roll jet activity. The Orion data is not crisp and clear, but it's fairly good. We'll continue to burn.
And we're about 100 miles downrange.
The predicted SECO from guidance is very close to the BET predicted within less than a second, so it should be very close to nominal SECO. Data is very good at this point from Orion, and everything looks fine.
Yes, sir. Our
Continuing to burn normally. Still burning nicely. Still burning well, still have good data, everything still looks fine. Approximately 30 seconds to SECO. Still looks like a very close to nominal SECO time coming up here shortly. Just lost data. Just lost data 2 seconds before SECO. We do not have an indication of SECO. We have no data from Araya. Still no data from Araya.
It doesn't necessarily mean anything is wrong. It means we just don't have any data.
I will say this, that we lost data about 2 seconds prior to SECO. At that time, everything looked nominal on the guidance data, the only data we had. Now we're past the nominal LOS time from Araya, so we should not get any more data. This means we do not have a predicted orbit. The best we can say is that 2 seconds before we were supposed to shut down, the orbit looked very good. The next data we will get will be from the next Araya down over the Antarctic continent. It's quite some time away, and at that time we will take a quick look and see what we can do. However, at this point, we have no indication of any anomalies whatsoever.
And we are 12 minutes and 47 seconds into the flight when we lost our data. The vehicle was traveling at 17,489 miles per hour and was 111.4 miles downrange. So our next data comes from Araya aircraft off the coast of Antarctica at about 37 minutes into the flight. And things will be fairly quiet here in the Mission Director Center for the next few minutes, since there will not be any data to look at. And as we said, liftoff was right on time at 3:24, and we're just coming up now on 14 minutes into the flight.
fire by the lock spit has been extinguished. No other major damage. The crews are out making their final inspections right now.
Roger. Oxidizer PTU is okay.
Roger, copy that.
LN2 Doer is okay.
Roger, copy.
Launch mount area looks okay.
Roger.
High pressure storage area is okay.
Roger, copy. Pad control, safety.
Pad control, go ahead.
Is the yellow team on its way in?
Not at this time. I don't think they're going to lift the roadblocks till we give Sergeant Parks the okay.
Roger, copy that.
LSM, OS Engineering.
Go ahead, Mike.
Yeah, is the data critique still set for 5 a.m.?
Okay, the
This is the
WB
OI. We had
is
a
okay. We got
one time reported by Araya 1 of 11:35:15.7. That was a SECO 1 time.
I believe
This is
I'll confirm it though.
Delta Launch Control at 19 minutes 42 seconds into the mission. We've had confirmation from the Araya aircraft that the data recorded on board shows that we had a successful burn of the Delta second stage, the first burn. That cutoff occurred exactly on time, and that data looked good. So at this point, we continue to be going along very smoothly. And the second stage will ignite once again at 37 minutes 37 seconds into the flight.
damage inside, couple panels and the O2 meter, but other than that, it's fine.
Copy, minor damage in the ACEB.
Correct.
Can you tell me what got damaged?
One of the control boxes for the spacecraft air fell off the wall again.
Again?
Yeah, same thing happened last time.
Roger.
Looks like the building got pressurized and it blew the door open. And like I said, minor damage on the interior.
Copy.
Safety and see if we can't get the securing team in here. It looks pretty clean out here.
Roger.
CSO, pack control. TC, pack control on 5.
Who were you looking for on 5? TCL 5.
Okay, I was looking for CSO. He's here.
Okay.
Yeah, Bob, I think the way it looks out here, we can probably get in contact with Sergeant Park if you can and go ahead and lift the roadblocks.
Roger, I've done that. He tells me another couple more minutes.
Okay. Just to give you a heads up, the last few items we need to check, we're running a blower down into the tunnel area so we can get down and check the heat exchanger, and we're checking the FUT, but other than that, it looks pretty clean out here. test conductor pad control.
TC, go ahead.
I've been informed on the FUT level 9 we have a vent valve that's stuck open and we are leaking nitrogen.
Copy. Level 9.
Correct.
And valve open. Is there any way to secure that at the base of the FUT?
We'll check on that.
Roger.
about now? 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 1, 1, 2, 3, 1, 2, 3.
This is Delta Launch Control at 31 minutes, 45 seconds into the mission. With us here now is Dr. Mario Acuna, the project scientist for the Polar mission, and he's going to narrate some videotape for us of some of the science to be accomplished by Polar.
Okay, what we see here is the sun, which is a source of energy in the solar terrestrial system, and the flow of the solar wind towards the Earth is a supersonic flow. It encounters the Earth's magnetic field, and it forms a shock wave in front of it, as well as a long extended tail behind the Earth. And many interactions take place in this region, as we see in the illustration here. Some particles flow around the magnetosphere, around the shock wave. Others enter the polar regions. Others go into what we call a ring current. These are regions of energy storage in our system, and they are very dynamic. And the polar regions, of which Polar is designed to study, are special because they provide access through the cusp, like a funnel, to the atmosphere below, and they cause the formation, the glow of the atmosphere when it's excited by particles. In addition to that, these particles flow outside and along the tail, the flanks of the tail, and they drift into the region of the tail, forming what we call a plasma sheet, which is another region of storage and energization of particles. These are very important because they can flow both away and towards the Earth under variable conditions. This is not a static situation. It's very dynamic. This tail can stretch and compress and oscillate as illustrated here. And it creates a number of problems related to solar activity, like geomagnetic storms. Again, the polar regions illustrated here, showing the axis of these particles, which eventually make the atmosphere glow, creating the northern lights or the aurora. Geomagnetic storms can also affect our systems, like pipelines and communication satellites, power lines, and so on, creating disturbances that can affect our services. So the study of the solar terrestrial system is a very important component of this. The orbit of Polar is designed to perch the spacecraft high above the polar regions and provide imaging for up to 10 hours each orbit. And this is a very important contribution to the International Solar Terrestrial Physics Program. The aurora seen from space is illustrated next, as we observe with an earlier spacecraft called Dynamics Explorer. We can see the dynamic evolution of the aurora, which has the shape of an oval as seen from Earth. And this reflects the solar activity as it falls down to the northern polar regions. Here in disturbed conditions, the power grid can be affected, as illustrated here, like associated with a large geomagnetic storm in 1989, and provide extensive blackouts throughout regions sensitive to this. Again, the study of the system is important, so we will be able to make predictions in the future.
And that was Dr. Mario Acuna, the project scientist, discussing the video which we were able to see, illustrating some of the science which Polar will accomplish. We expect to have some data in about another 7 minutes through the Araya and through the Japanese tracking station on Antarctica. But at this time, all of the information that we have, that even though we didn't have actual real-time contact with the last Araya when we had the initial second stage burn, we're hearing Skip Mackey. Now we're hearing data through the Orion. Here's Skip Mackey once again with data from the Orion. We are getting data from the Orion.
5. Okay, the foot inspection is complete. We just sustained some sighting damage.
We see Orion trying. We have not gotten enough data to indicate that we anything going on yet. This is earlier than their predicted AOS. This is their initial horizon break time. Okay, now we got a couple little samples of data there. Data looks to be slowly getting better. We take a look at what we can see. Again, this is PCM only. We are in a normal coast. The attitude errors are all where they should be, which indicates that we are in a good coast. Data is getting slowly better, but it is not crisp and clean yet. It continues to improve.
And we have about 5 minutes before a spacecraft separation.
We have an indication that we have restarted. Looks like it's burning. Definitely is burning.
Second stage up and burning.
We have SECO-2, burn time approximately 25 seconds. During the burn, we had normal attitude control, which means we must have had a hydraulic pump up. Burn time was pretty close to nominal. Okay, we have a second burn orbit. We didn't get a first burn orbit, but we had good data. The second burn orbit cut at SECO-2 plus 30 seconds, actually. Height of apogee 479, which is within a half a nautical mile of nominal. Height of perigee is 94.98. Nominal was 95.1. So it looks like, and its inclination 86.02 in both cases. It looks like in every case we are right on the money with the nominals coming from the guidance computer. That is an excellent piece of data. Okay, it looks like we have had spin up. We see spin up on the second stage. We should have separated by now, however, we have no way of proving that. It appears as though we had third stage ignition. Now, the way we get this is to see an indication of blast back on the second stage, and we see that on the gyros and in the acceleration. So it looks like we have a third stage ignition. Now, that's the last piece of data from the primary mission that we will get. From now on, all pieces of data will be voice. We continue to have good Orion data. However, we should lose it because they probably should be tracking the third stage. However, at this time, the limited data we have indicates that everything's going well. From now on, all the reports will have to come from the OI who's listening to the voice reports. So this is NASA TM signing off at this point.
And we just had confirmation that we've had a complete burn of the Delta third stage. And we're waiting confirmation now of spacecraft separation from the Mission Control Center at Goddard. That should be occurring in about another 35 or 40 seconds.
For a future reference, we have extremely good Orion data right now.
We haven't heard anything yet from the Orions.
Still have pretty good Orion data. We're well past the time of Orion's nominal LOS. However, we are right at their nominal horizon, and their data is just about gone. In fact, it is. So they held data right up to the horizon break, and we got excellent orbital data from it. So I'm off the air now for good.
And we're waiting to see if we will get any spacecraft separation confirmation. And we have word that we will not be getting any spacecraft separation data until the spacecraft reaches Madrid. So at this point, we will simply have to wait a while to hear confirmation. But so far, all the data the Orion gave us on the burns of the second and third stage all look good. And no reason to expect that anything did not occur as planned, but we just don't have confirmation of separation. So we will get that. And have that information for you, as well as the health of the spacecraft and how it's doing at the post-launch news conference, which is scheduled for approximately 5:30 a.m. Pacific time, 8:30 a.m. Eastern time. And so until we rejoin you again at the post-launch news conference, we've had a very successful launch on time at 3:24 this morning, and we'll complete our coverage at this time. This is Delta Launch Control.
Alpha Columbia for top.
Go ahead, Columbia.
Basically, the sequence is altered. We're turning top off. And from a visual standpoint, we can see when the filament is turned on, but no beam firing.
And Maurizio Top concluded that same observation. And since the FO is complete, you can go ahead and terminate the high voltage.
Roger.
Columbia Huntsville for sets. 4 Bravo ran smoothly. Sets reported good data on both FPEGs. Also for Maurizio, it was concluded the reason you couldn't really see an emission was due to the FPEG being in a hard vacuum.
We copy.
And I'm going to be handing over to Dorina. It was good work today, and I'll be talking to you tomorrow.
Okay, thanks a lot for your help. Okay, thank you, Ed. See you tomorrow. Houston, Columbia.
Go ahead, Columbia.
Yes, Story. I went down to the tip spinner, but I didn't see a new message sent up. Are you sure we have one coming?
We will send message 26 again.
Okay, thanks.
And we're assuming TIPS is on.
Yeah, we just checked it a minute ago. We'll go check again.
This is Mission Control, Houston. We're resuming our live coverage of shuttle mission STS-75 following this morning's successful launch of the polar spacecraft atop a Delta rocket. That, of course, took place at 5:24 a.m. Central this morning. In the meantime, here in the flight control room, the flight control team is continuing to work toward preserving its options for a deploy of the tethered satellite system this morning. This afternoon on schedule at 2:37 p.m. Central Time. The mission management team will be meeting a little bit later this morning to discuss payload communication issues. Right now, that is the only issue being worked by the flight control team. During that meeting, the mission management team will make a decision as to whether or not a deploy of the tethered satellite system will occur on schedule today or whether it will be delayed 24 hours. However, right now the plan is to proceed with this afternoon's deploy as scheduled at 2:37 p.m. Central Time.